All right, so this is similar to number 2, or it is number 2 rather, on the practice test. As we're going through here, I give you 2 points and ask you for the line. If you want to use or find an equation of a line, you need 2 things. You need the slope for sure, definitely. How do you want to find the slope here? What do you want me to put in the numerator? 7 minus negative 1? Okay, I'm fine with that. And then how about the denominator now? Negative 2 minus 3. So let's check this out. What's 7 minus negative 1? Equals 8 and over negative 5. So I'm going to write a 5 here and my negative up top because it drives me crazy if I don't. So where do you think the first point came from? That. Like, did you give me that value? There's your first point. Now, once we have it, I ask you for the equation. If you look directly above this problem, you should see 2 options to plug into. Should I use point slope or slope intercept? Why? Yeah. What would I want? What would I see in the x value if I wanted to be able to use slope intercept? If you give me any y-intercept, what's the x coordinate? Anywhere along the y-axis. 0. So if there were a 0 here or here, I would use slope intercept, but there's not. Which point are we using? I have no preference. First or second? Okay. So let's use it. Y minus, what's the y value? Negative 1 equals m, negative 8/5, times x minus 3, because we match them. We use this point. So that's okay. As we're looking at it, I'm just going to clean these up. And look at that. How many of you guys went further? Did you need to? Like, no. If you want to stop here, that's totally fine, because I didn't say find me an equation in slope-intercept or any particular fashion. This is for what the question asked for. Now, if we want to go a step further, Kennedy, did you go further with yours? No, but I got Yep, so you should have y minus 7 equals negative 8/5 x plus 2. Cool. That's a good answer. Now, if you went a step further, bless you, I'm going to clean up this one. I'm going to distribute here, just so we can see it in slope-intercept in case you went that way. Negative 8/5 x. What's negative 8 times negative 3? 24 over 5. And then I'm going to subtract 1 from each side. I'm going to do minus 1 here. Is there a better way I could write 1 on this side? 5/5 is a good choice. And it means that regardless of which point you used, if you went to slope-intercept, we should have negative 8/5 x plus 19/5. And we're done. Cool. All right. Number 3, as we went through it, I don't remember who asked, and who asked isn't really important. Where were your issues on number 3? No idea who was. Anybody can answer that, though. If you struggled with number 3, where were your issues? Okay, so if we solve a system of equations, just the concept itself, what are we looking for? Where the 2 graphs intersect if we were to graph them. So we could go through the process of graphing each of those lines individually, and that's all fine and dandy. Alternatively, we have an algebraic approach to these, because even if we graph them very carefully, we're not going to just blindly trust the graphs because we're not perfect. Okay, looking at this, did you guys use elimination or substitution? Okay, somebody in here tried to use substitution and things got wonky. It might have been 6th hour. I don't recall exact. I don't even know who it was. But let's check it. I don't know why this isn't working. Bizarre. We'll just take a look. Okay, so here we are. As we see this one, we have number 3 here. And let's knock it out. We have 8x minus 3y. 8x minus 3y equals negative 13. And we get negative 3x plus 5y equals 1. Now, if we want to solve this system, again, we could graph both of them, but we're not going to just blindly trust our answer. I want to eliminate one of these. Now, you could use substitution, but no matter what I solve for, I'm going to get what out of it? Like, if I solve for x, I have to divide by on the top one. So if I were solving for x, what would I have to ultimately divide by? 8, and then 3/8 and 13/8. So I get fractions. The same thing is going to happen whether I look at x or y in either equation. So that's my telltale sign that, hey, substitution is not very convenient here. Now, coincidentally, I noticed the x's and the y's both have opposite signs, which is pretty convenient. What should we eliminate? And there's no right answer. A y? Sure. Where's the first place that 3 and 5 meet? 15. So I need them to meet, but I need them to have opposite signs, which they already do. If I wanted this to be a 15, what would I multiply by? 5. If I want this to be a 15, y, what would I multiply by? 3. And I write these, and I always do it in this exact same form. What gets multiplied by 5? Everything. I'm doing it to both sides of the equation. We get 40x minus 15y equals negative 65. And we get, let's see, negative 9x plus 15y equals 3. What do I do with these things once I have both equations written? We add them. Like, I'm going to draw the bar straight here. We add straight down. 40 minus 9. 31x, they gone, right? 0y equals negative 62. Well, that seems like it's going to work out pretty convenient. If I want to solve for x, what would you have me do, Fred? Okay, cool. I'll do that. What do we get for x? Negative 2. So there's our first answer. Am I done? No, we're looking for the place on the graph where these things intersect without graphing it is really what we're doing. So I need to get a value of y. How on earth do I get a value of y? Yeah, let's plug in to which equation? The second one? Does it really matter? Good. So I'm going to say into either equation, either original. And remember, all these thought comments are just there for somebody who might need the extra little guidance. Plug this x into either original equation. And you said the second one? I'm cool with that. If we do that, we get negative 3. And I'm going to replace the x with a negative 2, so I'll just leave it blank for now. Plus 5y equals 1. What did we just find x was? And let's do it. So here we go. What's this turn into? 6 plus 5y equals 1. 5y equals negative 5. And therefore, y equals what? So y equals negative 1. Love it. Am I done yet? Not quite. So I'll tell you, there's 3 points on this problem, and we have 2 of them so far. So 1 point was, did you use a method? And I don't care if you eliminated x or y. It doesn't matter to me. You could use substitution, but you get to play the fraction game a lot. Your second point comes from, did you get the right values? Where do you think the third point comes from? What's the correct notation for writing the answer to a system of equations? It's an ordered pair. These things are points on the plane, so we should probably knock that out. Here's my formal end answer. Before I write it, is there anything that I should probably do? Can I check my answer? How? Plug in x and y into which equation? Both. We need it to be true in both. And let's just check before we commit to it. If I plug it into this one, and I'm just going to do it above, let's see, we have negative 16 plus 3. Is that negative 13? Yeah, and I'm just plugging in negative 2 and negative 1. And let's do this one. This would be 6 minus 5. Is that 1? Hey, they both work out, so I'm convinced my answer is correct. We have a single point of intersection between these two things, and there it is. Cool. All right. Going through, I'm going to restart my camera to see, because I don't think we need to work through every single problem. And maybe somebody does, but I don't think everybody does. Number 4 is definitely there. How did you guys factor as I'm trying to get this set up? Number 4a, what method did you use? Grouping, that's what I would use also. So here we are. When we group it, assuming that I don't have any issues with it, we should get negative 3/2 and 2/5 as my roots. Here is my factored form. Here are my roots. So each of these were 2 points. And sorry, I did give you 4 points here. Okay. So did you try it using a valid factoring approach? And did you get me the right roots? If you're missing one, I took off a half for each one that was missing with a maximum of -1 there. Okay. So any questions here? Okay. So on the second one, what did I use to factor? So definitely quadratic here, for sure. What about this? This is the sum of 2 cubes. Now, we have 3 versions of binomials that we look for: difference of squares, difference of cubes, sum of cubes. Okay, so my first factorization, I realize that this is the sum of 2 cubes, and we have it. Cool. All right, so as we're, oh, me? Okay, yeah. Cool, I'll have you guys check through this one. Let's dig into it. Yeah.
Did Lewis talk to you about the student teacher?
Briefly, yeah. Yeah.
Like, it's gonna happen.
Okay.
I want to know if you'd be willing to be teacher of record, or if Laura should, as far as like the actual mentor teacher. It's not.
I think I'm probably busier than Laura.
I would say that's probably true.
And we can divvy the labor if,
Yeah.
if she's willing to, like say like I'll obviously help out, but yeah. Whose classroom is she? Both equally?
Yeah, I think
Okay.
equally. I mean, it's Kim just said yes, so now I have
It's-
to kind of make it work.
Yeah, it is a good thing for the end of the year.
Yes,
Like it's
it is.
super beneficial.
So yeah, that's just kind of how it's gonna work. It's gonna be half an hour.
Okay.
But one name to put like.
Yeah, if Laura's okay with it, I'm okay with her doing it. But I could be convinced otherwise because I'm a people pleaser. All right. So checking it out, we get -2 here. Now, the natural thing that people do wrong with this problem, and it's okay if you've done this, but I have a sneaking suspicion that somebody in here got only one answer, and it was -2. Because you subtracted 8 and then you took the cube root. Anybody do that? One single root because you just subtracted 8 and then took the cube root. How many roots did you come up with, Ronaldo? Okay. So the most common mistake that people make is coming up with a single root by subtracting the 8 and then taking the cube root. Like, that's a pretty natural response. How do you know there's going to be 3? It's a third degree function. Kennedy. So first I did the difference, or the sum rather, of 2 cubes, which if you look back in, and I'll even, this is off of memory, so you're just going to have to maybe browse through. This is section 3.3. And we're using the fact that a cubed plus b cubed becomes a plus b, the cubed root of each, and then the first term squared minus their product. This rule. This is a polynomial identity that we have seen. That's what I use to factor it. Once I do this, I keep kicking. Now, if you got to here and stopped, I would give you credit still. If you see everything has a 2 in it, we should simplify it down. But realistically, if you stopped here, I would give you the point. Cool. Sonny. Okay. So 3 roots, -2, 1 plus I root 3, and 1 minus I root 3. Cool. Kennedy.
On the left side.
Okay.
After you get like the 2 points from taking out 2x and 3, once you get that go down. That step after that, how did you get the fraction?
So if I were to solve this equation, 5x minus 2 equals 0, what would you do first? And then you would divide by 5, I assume, and there it is. Yep. Cool. All right, on number 5. Here we are, looking at this. Did you use Pascal? Which my hope is that it's not taking up a gigantic amount of space on your note sheet. But I did sketch it out to get the first 3 or 4 rows, depending on, it should be the first 3 rows, right, because we started 0. But we should get 8x cubed minus 36x squared plus 54x minus 27. Cool. If you foiled it all out, I would not give you the points for using Pascal. If you foil it all out and get it right, I'd still give you one of the 2 points, just so you know. But I want to see that you're using binomial theorem, which is Pascal's triangle stuff. All right, on this one, there are a lot of ways to go through it. It is A, just so you guys know. What I'm more concerned about, because you have a 25% chance of guessing this, I'm not going to make you guys like complete the square and do all that fun stuff that I know everybody loves, but we do need to be able to make sense of these. What are your guys' justifications? If you got A, Sonny, what'd you use?
I said that h and k equals 4 and -2.
So I'm going to pause there. Where are you using, what do you mean h and k? I don't see an h and k here.
The -4.
So let me be more specific. Where would h and k show up in this form?
I don't explain, but it's right there. If that makes sense. You know?
No.
Can I point to it?
No, I want you to tell me what the general form of this is, because there's no h and k anywhere written. It's a times something, I think.
X minus h k plus k plus k. Oh, squared plus k.
There it is. Plus k. Where h comma k is the what? Not the,
No.
maybe the x and y, but be more specific. Which x and y?
Vertex.
The vertex. Cool. Now, looking at this, I saw there's a couple of people when they took the test initially, and you guys are lucky because you get a practice test and not everybody else did. So that's pretty sweet. Looking at it, Sonny, I agree with you. Only two of these choices match this vertex. It needs to be x minus 4 and then a minus 2 outside, right? So I already know it's A or C. Now, what's the biggest, or what is the difference between A and C here? One's negative, one's positive. Could I write this and plug in h and k and then plug in the x and y and solve for the value of A? How many of you guys did it that way? That's good. Like, that's fine. That's awesome. There's an easier way. What did you do, Sonny?
I just made a graph.
Okay.
It was like a sketch graph.
So fair. Don't know that I think that's necessarily any easier, but check this out. This is my vertex at 4, negative 2. Now, your graph is kind of going to help, I think, because we're going to think about the same thing depending on how hardcore you graphed. The next point is 2 away. Did it go up or down?
Yeah.
So if it went down from the vertex, the leading coefficient must be negative, which means if I had already locked in either A or C because of the vertex, which one is it? We don't have to do any real hardcore stuff if you understand what's going on. I know that this winds up a maximum because when I go 2 over from it, I'm down lower. I had this parabola. Only chance is if it's a negative leading coefficient. Cool. All right. If you did all the work, I'll make the box bigger if you want to do it the long way on the actual test, just so you know. Like if you want to work it all out, I'll give you more space to work, although you probably just worked in this big empty space down here. Cool. All right. Questions on this page? Cool, cool. Okay, number 7. Are we just doing it like all together? Okay. So let's see here. We get a wonderful cubic function, and let's see it. Number 7, we get this function, f of x is 6x cubed plus 31x squared plus 25x minus 12. Right off the bat, before I even do anything, and I know that we're looking at the whole problem, but the very first thing that I do in my head as I'm writing this is I immediately think, hey, I just wrote 4 terms. I hope grouping works. So I'm just going to look real quick. Is there a common factor other than x, like an x squared comes out here? That's it, right? Is there any chance I'm going to make this say 6x plus 31? So grouping is already out for me, but that's okay. On A, they ask about M behavior. Now, there's a few ways you could do this, but I prefer always easier if possible. There's some sick dance moves that come to mind. How do we know which move we're doing? What's the LC? Positive, so greater than 0. Cool. What's the degree? Odd. So if it's positive and odd, it looks like the graph of y equals x in the end. Down to the left, up to the right. Cool. That's it. If you gave me the justification, you got a point, and you had to justify both of them. If you gave me the end behavior, did anybody write the as x approaches infinity statement instead? Fair. All right, on B, we want to know the possible rational zeros, which is a what list? PQ, or rational zero theorem. So where do we get P and Q? Okay, so constant and the coefficient, right? Like those are the two that we're looking at. Kennedy, which one goes on top? Good, because it's, I don't care how you remember it, but I remember it because further right means up, bigger. Okay, so what are the factors of 12? Let's list them out. 1, 2, 3, 4, 6, 12. Okay, there's all my possible numerators. Divided by, what goes in the denominator? 1, 2, 3, and 6. Okay, if you stopped here, I'm good with it. You do not have to write the whole list with all these possibilities. I'm A-okay on the test when you get here, because you will see a question like this. Stop here. Don't write out the whole list. If you did it, like, it didn't hurt you at all, but we don't need to do it always. Okay, now, normally, depending next year at least, and depending on how many calculators I have next year, maybe in Algebra 2 also, normally what I make people do is using your calculator or synthetic division, you start guessing and checking. But we don't have an infinitely large list. I hook you guys up. What do I suggest might work? So let's try -4. Now, if x equals -4 is a root, here's the important part. We need, on this problem, we need all the factored form, like the completely factored form and all the roots. So x equals -4 is a root, or a 0. I like the word 0 here. What's my factor? X plus 4 is a factor. So I already have that. When whether you physically write this down or not, I did physically write it down on mine, because this connection is huge. X equals some constant, x minus that constant is the factor. We can always just get to it. Now, how on earth do I find the other factors? If I say that 6 is a factor of 30, how do you get the other one out of it? So you divide. So I liked your answer, and I don't know if everybody heard it, so I'm going to hold off on it, Hawaii. Do you guys want to do long division? We could, but what's better? Let's check synthetic to make sure that I wasn't like lying right to your faces. What goes outside of the synthetic box? A -4, the root itself. What goes in the top row of the synthetic box? I'll scroll up here. 6, 31, 25, -12. We are not missing any powers. So here we go. 6, 31, 25, -12. What should the remainder be, as long as I haven't lied to you? Should be 0. Now, here I am, and I feel kind of embarrassed about it, but I don't remember how to synthetically divide. How? Well, there's a correct answer here. Like it's hot, that's right. Okay. 6. Now what? -4 times 6 is -24. Cool. Now what? So whether you say add or subtract, I'm okay with it. In my mind, I'm thinking add the negative, because I'm going to add no matter what. But Kennedy, you're right. It does wind up subtracting. I think you get 7, right? And -28, -3, and 12. And look at that. 0 did work. So we've confirmed then that I was telling you the truth, and I gave you the nice place to start. At this point, can I write a mostly factored form of f? Okay, hardest part of the problem right here. What's one of the factors already? We already knew it. X plus 4. What on earth do these numbers represent? Just for the record, I'm not going to answer this one. I do get paid no matter how long we sit in silence. So I'm going to let you guys chat for a second, and we'll just wait. The 0, I don't know if I agree with that. I would talk it out with your neighbors and find an answer to shout out. Ooh, say that louder, Chetty. The coefficients of the quotient. Now, we started with x cubed, right? And we just divided by something with x. What would my new quotient power be? Has to be squared. So here it is. I'm going to do it in purple so it stands out. 6x squared plus 7x minus 3. Okay, we're not done, but we're close. And maybe we're done, but we'll have to check. I just asked you to write it completely factored. So we need to check. Question mark? Oh, no. That is a new phrasing that is going to become a regular usage, just so you know. Because it sounded like I was punctuating something. Question mark? Love it. All right. X plus 4 hangs out with me. Yeah, well, get a glimpse into my head. Yep, right away. That's all I heard. Okay, I'm going to do some scratch work over here. Now, just to make my stuff look a little bit nicer, I cannot factor x plus 4 any further. But I should think about this. So I'm just going to rewrite it, and I'll do the scratch work over here so we can have a nice answer at the end. I'm trying to factor this. What's the first step in factoring, like always? GCF, there is not one. Bummer. Is it a binomial? No. If it were, what are the 3 things I would check for? Difference of squares, difference of cubes, or the sum of cubes. But it's not. Okay, we're good. It is a trinomial. I want the leading coefficient to be a, but it's not. So that's a bummer. I don't have a shortcut. I might think about perfect squares, and then I realize, do I know the square root of 6? I don't. So it's not a perfect square trinomial, which means we're down to which possible option. That's my phone, by the way. I'm sorry. Grouping. What's 6 times negative 3? I now need two numbers that multiply to be negative 18, but what must they add? 2. 7. So let's see. It's not 1 and 18. Hey, 2 and 9 will do the trick. Which one needs to be negative? The smaller one. So there it is. How do I use these numbers then? Like, what's the next step in grouping? So we can't do 2 factors because you're trying to use a shortcut. I'm going to replace the 7x, the plus 7x rather. Let me underline or move that so it's not covering. I'm going to replace that with these. Like, we rewrite our 3-nomial as a 4-nomial, and let's do it. So here we go, 6x squared. And I'm going to leave some awkward gap because I'm going to make them yellow so they stand out. Minus 2x plus 9x. Now, I have an equivalent expression. It looks a little different. It just has 4 terms. But that's convenient because now we can do what? We can group it. Common factor between these two. 2x leaves behind a 3x minus 1. What possibly could factor out of here? A 3, and it leaves behind a... Is that a good sign? In fact, it's the best sign. It's the only sign that I need because this tells me I'm right. If they match, we're done. Which means I get 2 more factors here, and I'm going to write them now that I've done it. All my scratch work off to the side. Give me another one of these factors. 2x plus 3, I heard somebody say. There's one more. 3x minus 1. At this point, here is my entirely factored form of f of x. There's half the question. The other question said, hey, don't only give me the factored form, give me the what? The roots, all the real roots. So here we go. We'll just go ahead and write it out, our roots. And we're just going to set each of these factors right here equal to what? So this one's easy. Negative 4. And I just set x plus 4 equal to 0. I subtract 4 from each side, and here we are. This one, if I set it equal to 0, I will subtract 3 and then divide by 2. So there's my negative 3 halves. This one, I would have to add a 1 and then divide by 3, 1/3. Okay. 4 points. Did you do division? Did you write it in its factored form? And did you factor the quotient further? There's your 3rd point. And did you give me the roots? As we're looking at it, just so you can see, here they are. Did you divide? And they're out of order. Did you get a quotient? Did you give me the factored form? And did you give me the roots? If you gave me the factored form and you happen to stop, say, right here. Just kidding. Right here on this one. If you stop here, I won't give you the full marks for the factored form, and you'll likely miss some points on the roots as well, because a 3rd degree function should have how many roots? 3, or 3 factors, if depending on how you want to do it. Cool. And the last one is construct a number line to make a rough sketch on the provided plane. I did not provide you a plane. I will on the other test. That's my bad. But how do I use a number line to help me sketch it? Do I know the end behavior already? Do I know the roots? So the only thing that I don't know right now is when is it above and below, right? Now, it's going to possibly be between our roots. What numbers go on the number line? Negative 4, negative 3 halves, and 1/3. And no other numbers are going to go on my number line. Now, it's at this point where either you're comfortable with it and we're going to save some time, or you're not. But I want everybody to be comfortable with it. How many intervals did that make when I cut the x-axis at those places? There's 4 of them. How many numbers do we have to check, though? Nope. 1. 1 single number is all we need to check. Now, anybody have a suggestion for that 1 number that we check? Negative what? I don't know. I thought I heard negative. Sorry. I could pick like negative 50 if I wanted. Doable, but it's probably not what I would pick. You could pick negative 2 or negative 3. I would probably pick in this interval. 0. That's 100% what I'm going to pick. Now, if I plug in a 0 into this function, and I'm going to look at the completely factored form, this is what I'm plugging into right here. Let's check it out. What's 0 plus 4? What type of number? Positive. What's 0 plus 3? Positive. What's 0 minus 1? Negative. Positive times a negative is negative. Why is this the only number that I need to check? Starts with an M and rhymes with synchronicity. Multiplicity. Now, this is a huge shortcut. If you want to use it, you can. You don't have to. You could pick some values here. You could pick 1 and negative 2 and negative 5. That works fine. But if the interest is trying to do less work, we should use this. How many times did any of these roots show up? Once. Or if I reword this question, each of these factors showed up 1 time each, right? Is 1 an odd number or an even number? Because each of these have an odd multiplicity, they show up an odd number of times, I know the graph does something specific. It crosses. If it was negative, what is it here? Has to be. There's no other option. If it was negative here, it must be positive here and negative here. Now, cool. If you don't like this, that's okay. You can spend an extra 60 seconds and you can pick numbers here. You can try x equals 1 and x equals negative 2 and x equals negative 5 or whatever number you want, really, as long as it's in that interval, and you'll get the same answer. But what I do see right away is this does agree with my end behavior because it said down to the left, up to the right, which that's certainly what it does. On the left side of this, it goes down to negative. I'm going to sketch this very, very roughly. So here we go. Let's sketch it. Only a few numbers that I really need on my x-axis, and I'm not going to put any on my y-axis. What are the numbers that I need to put here? Negative 4, so we'll say it's here. Negative 3/2, so maybe it's there. And 1/3 is like here. And my scale's not great, but that's okay. Now, I know it ends down here and up here due to the first part of the question. And all I have to do is at each one of these, it crosses. Okay, so it crosses. I don't know how high it goes, but is that okay? Yeah, if we're just sketching, it wouldn't do that little jagged thing. But it'll cross again. Now, this one is entirely up to you, but I do like to just check this out. If I was at 0, what would the y value be? Excuse me, negative 12. So I know it's fairly low. I don't have a scale, but it's just nice to verify one more way. It might look something like this. And I bet it does look something like this. Cool. We have the sketch. We done. Cool, cool. All right. Last one. Fill in the blank for these. Oh, go ahead. So 0 was just coincidental here. Typically it'll work, but it depends. I'm going to put these numbers on the number line, and then all I'm doing when I'm looking at these, and these are the possible values that I would have checked, is I'm just looking in this little range right here, what values of x, like what's the easiest value of x I could plug in, and it'd be 0 in that situation. What's it? Give me any value greater than 1/3 that might be easy to plug in. Good. Give me something between negative 1.5 and negative 4 that might be easy to plug into my function. Like, that's how we make these choices. Cool. All right. The last page was 6 total points because there were 6 blanks, right? Okay. For this, greatest common factor. Now, as we're going through, we check, is it perfect? And the order is kind of in the right order. Could you guys tell that what was connecting to what in this? Okay, yep, I don't know why it didn't come out very bold. I really wish that I'd known about this ability when we made our first factoring stuff, because this isn't super nice. Okay, we check for a perfect square. Then we hope it's a leading coefficient of 1. If it's not, we can try to do grouping, and if it fails, we'll use a quadratic formula. Cool. Over here, we check for the difference of 2 squares. And I didn't write it as the 2 cubes because it's kind of implied if we're talking about it, but the difference of cubes is the only other missing one. And then finally, what if we can't factor it like a quadratic type? What's the only thing we can use? What if it's not quadratic? Rational zero test will work. Cool. Okay, overall, if this were the graded test, this would have been worth 33 points. Your performance here is probably going to be pretty similar to how the actual test goes. How'd it go? Thumbs up says, yeah, pretty awesome. Thumbs down says, ooh. Okay, we have about 12 minutes in class. What I would encourage is any of the things that on here that you struggled with or that you need to check your notes with is what I would very strongly advise go on your note card. Okay, by note card, what do I mean? Note paper. You guys get a full single side of an 8.5 by 11 sheet of paper. You will be able to fit more than you need for sure. Cool. I'm going to let you guys have the last 12 minutes to kind of work on your cheat sheet stuff. If you have specific questions, just let me know. I will come around and we can work through whatever types of problems you want. Cool, cool, cool. The time is yours. I'm going to close this. Yeah. Would you like some? Okay. What color? Let me look. I got a few.